Welcome back, dear students, for electrostatics, one of the most important logical questions. So here we were. So following the same, that is, Feynman's electric potential is a non-uniformly charged sphere is not the same. In non-uniformly charged sphere, the charge density is different at different points. Due to this, the electric potential is different. So this was another reason to explain the previous one. So here it is. What is an equipotential line and equipotential surface? Equipotential line and equipotential surface. These are the 2 points. If the electric field in the electric field there are points which have the same value of electric potential. If you draw the lines in this space, you are moving up to the same distance in any direction. If the charge Q is at the center, each point on the surface, you will be getting same value of the potential. So such type of the surface is called equipotential surface. So it is also called Gaussian surface, a line drawn through the equipotential points in the electric field is called equipotential line. So this is the line drawn which shows the potential of the point due to the charge. Usually the Gaussian surface around the point stationary charge at which the electric potential is same at each and every point is called equipotential of the surface. So if you look at this is basically concept of the electric potential. You move at the same distance from the charged particle. In any case, you are getting either you move in this direction, or you move in this direction, or you move along this direction. You will see that along every direction you are at the same distance from the point charge. So this clearly shows that the field strength will be same at that point. Such type of the surface at which the strength of the field is same, that type of the surface is called equipotential surface. So here are some of the examples you see in the figure. You will come to know that these are the same distance, so that's why they are having same value of the potential. And other alternative answer is that a line which contains all the points which have the same value of potential is called potential line. For example, for a point charge, these lines can be considered as circles centered at a charge, which we have seen in the previous. For straight charge conductor, these are the straight lines we have seen in the previous one. Equipotential surface, a surface which consists of a set of points all having the same potential is called equipotential. Where it is possible in case of circular surface. In case of spherical surface, where all types of the particles at the same charges at the same distance from the center. So in each direction, the equipotential surface appears in the form of circles which the charge at its center. So for a long line of the charge, the potential surface appears in the form of cylindrical surface with the line of the charge along the axis, as we have discussed. If you look at this one is D, and here it is explained with the help of the D, and here it is C, where it's spherical. Here is a straight line. If you look at move on each side, you will be getting the same value of the potential. It is spherical, and again you can understand what's the value of the potential at each surface on each side. So I thank you very much for your patience.